Okay, we are at the examples now, and I tried to leave in view what we're talking about the perfect square trinomials. And let's look at number 44 from page 444. A lot of fours there. We're going to still use the steps that have gotten us this far. We're still being boringly good at factoring. We're going to ask the same couple of questions over and over again. We always check for a GCF. Is there something that all three terms have in common? In this case, no. And that'll occur a lot, but every once in a while, they'll throw one in with a GCF, so we want to be ready by always checking for it first. Second thing we ask ourselves is how many terms, and again, we're in the section that's dealing with perfect square trinomials, so this is going to be pretty boring too. The answer is always going to be 3 in this particular section. The reason why we always ask these, even though it's boring, is because pretty soon all the different factoring problems will be mixed together, and you're going to want to check because specifically the GCF will get you started right. Secondly, the number of terms determines what you will do next, so you don't just flounder around and try a bunch of factoring that's not going to work, okay? So make sure you get in the habit of asking these two questions. Now, up until today, when watching this lesson, your choice for 3 would have been trial and error, convert 3 to 4 so that you had factoring by grouping, but we're adding a third option here today, and that's if it's a special form. So in the book, they talk about using trial and error, just drawing in the parentheses and seeing what will work until you find a fit that matches and makes the right factors. We talked about in the lessons, and they also address this in the book as well, but we talked about using a split 3 to 4, convert to 4 terms, so you can factor by grouping. Okay, and now today we're going to see if it's a perfect square trinomial, use the special formula. So what does that look like? Well, here's our x squared minus 10x plus 25. Our a value, which is the number in front of your x squared, is 1. Our b value is negative 10. And our c value is 25. Okay? And actually, we're just going to worry about we won't worry too much about the negative. We're just going to do just really focus on the 10 right now. The negative will come into play in just a little bit. Just note that it's negative right now. Okay. And again, we're going to treat this, you could do it the convert to 4, factor by grouping. You could mess around and do the trial and error. I really do not have a preference which method you use. I want you to be familiar with all of them so that you can make the best choice for yourself. When you look for a perfect square trinomial, you ask yourself, is 1 a perfect square? Okay, so 1 is a perfect square number, and then you find the square root of that. Square root of 1 is 1. 1 times itself equals 1. That's what the square root means. Okay. And then you ask yourself, is 25 a perfect square? And 25 is also a perfect square number. And the square root of 25 is 5. And then you look at those two square roots and you say, is b, so b is 10. We know it's negative, but right now we're just focused on the fact that it's 10. And we say, is 10 the two square roots multiplied together and doubled? Double 1 times 5. Well, that would be double 5, and that would equal 10. So 2 times the two square roots together. So 5 times 1 is 5, double that is 10, and those do equal, and that equals b. So we have a perfect square trinomial. That's all you're doing, is you're just testing to see if it's a perfect square trinomial. Most of you who decide to use this method will be able to do these in your head, and that's the time saver here. I'm just putting it out in notes so you can follow along what's going on. Once you confirm that you have a perfect square trinomial, then you just write the factor, I almost said envelopes, you write the factor parentheses, and you put in your square root of your a value, in this case it's 1, your square root of your c value, which is, it's 1x, or just plain x, your square root of your c value, which is 5. So that's how you get your x squared, and that's how you get your 25. And then you match the sign of what you started with. It's negative, So that's how we match the sign. We make these both negative. Okay? And some you might see the answer written as a binomial squared. You might see it as x minus 5 quantity squared because they both exactly match. Okay? So you could write that as x minus 5 quantity squared, or you could write it out as the two factors x minus 5 times x minus 5. Okay? So that's an example of how you use perfect square trinomials. The time is spent checking to see if you have a perfect square, and then once you do, you just put in the pieces, match the sign of the middle term, and there's your factors. You don't have to try to split, you don't have to do trial and error, anything like that. Okay? So let's look at number 70, because there is a typo here in number 70 I wanted to highlight for you. It should have been 50 here, just plain old 50. Okay, 50, not 59. 59 would give us major headaches and it wouldn't match what we were doing. So, should be 50 here on the notes. And being the boringly good factors, is that a real word? That we start by asking ourselves, is there a GCF? Is there something that all three of these pieces have in common? And in fact, there is this time. It's so good that we check for that. It's so good we're building that habit. The 2 can go into 50, 20, and 2, and there's a y that they all have in common. So we're going to pull out a 2y for starters, leaving behind 2 times 25 will get you 50, and pulling a y out leaves behind a y squared, so 25y squared is your first term. Dividing by 2 here, you get a 10y, or divided by 2y, you get a 10y, and then divided by 2y here, you get a 1. And these numbers are actually quite similar because we had a 1 and we had a 25 in our first example. We had a minus 10, this is a plus 10. Let's look to see. Now, just to help us out here, help myself out, because I know that I can get excited, get going on something, and totally forget that this GCF is part of your final answer. So I'm going to put it down here. Okay? I know I'm eventually headed to some sort of thing like this. I want 2y to make sure to be a part of that final answer here. And now my second question is I ask how many terms I have left to try to factor. And in this case I have 3. No big surprise. That's why we call it being boringly good, because when we're in these original sections, they focus on one type of problem. Later on, not too long from now, we're going to mix these all together, and these 2 questions, especially number 2, become critical because the answer will tell you what to do next. 2 terms, you look for formulas. 3 terms, you decide if you're going to trial and error, convert it to 4 to factor by grouping, or if you're going to look for this perfect square trinomial like we are learning in this section. If it's 4 terms, you go straight to factoring by grouping. You don't pass go, don't collect $200, just straight to factoring by grouping if it's 4 terms to begin with. Okay, but because we're in the section on factoring special forms, perfect square trinomials, we're going to see if this one is a perfect square trinomial. So we look at the first number, the a value. Our a value is 25, our b value is 10, it's a positive 10. And our c value is 1. We just care about the 10. We'll deal with the sign in a little bit. Okay? And in fact, 25 is a perfect square. And in fact, the square root of 25 is 5. And our c value, 1, is a perfect square as well. And in fact, the square root of 1 is 1. And then we're checking to see if doubling the square root of a times the square root of c. So now what we're doing is we're checking to see if 2 times the square root of a square root of c, in other words 2 times 5 times 1, does that equal b? And in this case it does equal 10. So we do have a perfect square trinomial. And again, you'll be able to do this in your head once you get used to it. I'm writing it all out so that you have it as a reference in your notes. You do not have to write this all out once you figure out this method. Square root of 25 is 5, square root of 1 is 1. These are perfect squares, 25 and 1. You take the 5 times the 1 and double it. You get 5 times 2 is 10. Does that match? Yes, it matches b. It matches our b value. Now, if that's the case, then you take those square roots, and those are your factors. Now, don't forget the letters. So it's not just 5, but it's 5y. And 5y, and then it's the square root of that, it's 1, And then we match, the sign here matches our b term. In this case, it was plus, so we're going to make both of these plus. So there's our final version, 2y times 5y plus 1 times 5y plus 1. Now the book might have it written as, and I'm sorry to kind of squish in here, but we're still on this problem, so it's kind of say, or they might write it as 2y 5y plus 1 squared. In other words, just save a little chiseling here, save a little paper and ink. That's the exact same factor written out, so we'll condense it and use an exponent to express that it's 5y plus 1 times itself. So there's two ways to write those answers. In my opinion, in this class, for our purposes, either one of these versions is fine as your final answer, writing it all the way out or using the exponent notation. Now remember, we're factoring, so once you've split it all out like this, you're done. You don't want to start distributing or multiplying it out because you'll just work your way back to the original problem. We don't want that. So take a moment to kind of talk this through, either just to yourself or find a buddy, somebody you can talk it through so you can explain what's going on, and that's a real good step towards understanding it fully and being ready for the exam. And make sure you copy the notes, write down any questions you might have, bring those to class or whoever your help resource is. And then I want you to try number 48 here and pause the video. And there's another one to try too. There's 48 and 62. You can try either of those. Pause the video, come back, and we'll see how you did. So for 48, the answer that you should have gotten would be x plus 12 times x plus 12. It is a perfect square trinomial, or you could write that as x plus 12 quantities squared. Those mean the same thing, and that's still factored form. For number 62, again, if you would like to pause it, now would be a good time so you can try this on your own. The answer for number 62, the factored form, is 3x plus 8y, 3x plus 8y, or you could write that as 3x plus 8y, the whole thing squared, because they are identical and being multiplied by each other. I'm hoping that some of you have established a habit now of when the problems get bigger or more complicated looking, you pause and ask yourself, what's different? What's making this feel so much more complicated? In this case, it might be the fact that there's y's involved as well. But then you reassure yourself it doesn't change the steps. I still look for the square, perfect square, perfect square. Indeed, it was 3 times 3 is 9, 8 times 8 is 64. I take that square root, 8, take that square root, 3, multiply 3 times 8 is 24. Does it double to give you 48? It sure does. So we go ahead and take that square root, 3x, take that square root, 8y, put them in place for the factors, and then match the sign of the b term, plus and plus. And once again, just to be super duper clear, you don't have to do it this way. Using perfect square trinomials, okay? You don't have to do it this way. There's a little bit of a benefit to it later on down the road, but you're also going to hit this again in Math 95. So we're just really planting the seed. Your call whether you're ready to memorize yet another formula or not, okay? It is a time saver. But you don't have to do it this way. The strategic, whoops, helps if I spell it right. The strategic split from 3 terms to 4 terms that we learned about in section 2.3 and 2.4, the strategic split from 3 terms to 4 terms will always work too. May take a little longer, may get some pretty big numbers because of the squares here, but it will work.